No unified perceptual scale defining user preferences across different peak luminance and contrast values in HDR displays exists. Our goal is to build such a scale with parameters relevant for VR. In order to do this, we constructed a wide field of view stereo HDR haploscope setup which can display a wide range of luminances. This display is able to reproduce a peak luminance of 1000 nits and a contrast ratio of 1,000,000 to 1. The field of view of our haploscope is 65.7 degrees and it has a display with 29.2 pixels per degree. To measure preferences, we conducted a user study with 12 HDR videos in 4 categories representative of VR content. This includes productivity, faces, user-generated content and pass-through, and entertainment content. Displays with different dynamic ranges were simulated via tone mapping operators or TMOs. We studied 5 contrasts and 5 peak luminance levels which span 3 orders of magnitude. In this work, we studied 1 simple and 1 complex tone mapper to show that the selection of tone mapping operator has a non-trivial impact on visual quality. Here we show visual differences between the two and see that the simple fixed TMO clips details which are visible in the complex content-aware one. Our user study consisted of 612 conditions in total, which was split into 4 sessions. During each trial of the study, we showed users 3 videos on our haploscope. The reference video mapped to 1000 nits peak luminance and 1,000,000 to 1 contrast, and 2 test videos with reduced dynamic range. Participants were asked to select a test video closer to the reference in terms of both brightness and contrast. The results of the study were scaled to just objectionable difference units or JODs. We found that preferences saturate for high values of peak luminance and contrast. We fit a computational model to this data which predicts JOD scores given a display's peak luminance and contrast. Here we show a rendered surface fit predicted by our model. A new study was conducted on an HDR VR prototype head-mounted display to determine if our model could generalize to a realistic VR scenario. Users were shown the reference scene and a test scene tone mapped to 3 different peak luminances. They were then asked to rate the quality of the test scene using a 5-point scale. The user rating results were scaled to mean opinion scores and plotted against the model predictions, where higher measured scene contrasts correspond to larger scatter points in this plot. We found a strong correlation between our model predictions and user ratings, which indicates that our model can predict the results of this VR scenario well. Our model can be used to predict the quality of a display given its peak luminance and contrast. Here we show a heat map of predicted JOD scores with iso-JOD contours plotted at 0.5 JOD steps. We can predict quality scores for popular commercial home theater, laptop, and television displays, as well as a variety of industry standards. This model also allows us to discuss trade-offs in display design. At 2.04 JODs, we can either have a display with 400 nits and 1300 to 1 contrast, or one with 300 nits and 5580 to 1 contrast. A manufacturer might choose the 300 nit display if power consumption due to high luminance is a concern, or they may choose the display with lower contrast if optical elements that achieve high contrast are costly to produce. Either way, both displays have the same quality score. Thank you.